Oh, yeah, it's all right. A little bit of an echo for me, but I can, yeah, hear.
Okay, so we are also live on YouTube, and I'll just give you a quick update from here. So it's like almost morning here, like 5 a.m., 5:30 a.m. actually. So we have spent whole night working on different things. There were different sessions, and working on a lot of things. Uh, Many of like almost all of them were able to complete their project, and many of them are even uploaded on the GitHub thing. I see that you have also seen gone through the demos.
Yeah.
Yeah, over to you. Maybe questions at the end of your talk. But yeah, first we are very excited to hear from you about virtual reality, your session now.
Okay, let me see if I can share my screen.
Yeah, sure. So over to you, Kevin. Now.
All right, do you see everything? All right. Is everything looking
Yeah,
good?
it's
Wait, do you still see me? Is that, I'm not sure what it's looking like over there. Oh, I think it's just showing my screen, right? Hello?
yeah. Please go ahead.
Okay. Yeah, so I'm Kevin. I work on the Mozilla VR team. I started working maybe probably on VR about almost a year ago or a year ago. And I've been working with Mozilla for maybe 4 years now. I started as an intern in college, and then I slowly moved up to being full-time. So I'm a web developer, and I currently am a core developer on A-Frame, and everyone knows it's a web framework for building VR experiences. And we wanted to build it because we really wanted to help push web VR as a platform. We didn't want it to be like mobile, where the web was 4 years too late and native had already taken over. And in this case, web VR is there pretty early, so it's something that can actually be successful. But in order to be successful, you need a good content and good ecosystem and developers that know how to build content for web VR. So that's why we built A-Frame. We wanted to make something that's easy to build not only 3D content, but VR content, and bring the whole web community into the VR mix. So everyone knows, or everyone already played with the code, but it's just HTML. The beautiful thing is there's no build steps required. You just have a index.html file. You can just put HTML inside and it just works. And that means that you can use it with CodePen or JS bins. And HTML is something that everyone really easily knows. So you just put basic shapes in your HTML. And here's an example that someone from Samsung, Ada Rose, made. It just uses the text component. And yeah, you can actually make a pretty scenes just with HTML alone. And the beautiful thing with HTML is that it works with everything in the web ecosystem. So you can use React, D3, Vue, Angular, jQuery, Ember. This is because we use custom elements, and every web framework is built on top of pretty much HTML. So when you have HTML as the bridge between WebGL and everything else, it just works out of the box. And did you explain the any component system yet?
Yeah,
Hello?
we have explained them. Yeah.
Okay. Yeah. So I'll just go over quickly. So yeah. So everything in a scene is just pretty much a blank object, and you plug in components to give it appearance, behavior, or shape. So the analogy is like Minecraft. Everything is a block, and each block has different components that give it different attributes. So the TNT block would have maybe like a material texture that gives it the TNT look, and then it also has a component to make it explode when it gets hit. Or maybe a torch component has a light component attached so that it emits light. And how it works is in HTML, yeah, you have an A entity, and then you just apply HTML attributes to plug in different components. So you have a geometry material component to give it a shape and color or appearance. Position, rotation, scale, those are also components. And say we have an animation component, then we can just plug that in and it'll automatically just give it some movement, or if someone makes a movement pattern component, which we're currently working on for one of our games, it gives it like enemy movement. You can just plug that in and it'll start to move as you define it. Or you want to change the appearance, you can just swap out the geometry material and just plug in a model component. And the beautiful thing is that anyone can write a component that can do pretty much anything. So to register a component, this is kind of the lifeblood of A-Frame. You can write a component to do pretty much anything you want. We have a system to register components that people can share, and anyone else can just grab those components, put them in their HTML, and then just use them from their HTML. So the structure is you have a schema which defines which properties you're going to have and which types those properties are. So if you had a foo property, you can see in the bottom, you can just specify it with HTML and same with bar. And within your everything else after that is like init, update, move. Those are all handlers. So in certain cases, A-Frame as a framework will call those handlers in certain cases. And within those handlers, you can use your data to do whatever you want. So you have full access to Three.js. You have full access to any JavaScript API, WebRTC, WebSockets, speech recognition. You can make any API calls you want. You just wrap that all up and you just use it straight from a component declaratively from your HTML. So what this does is anyone that's skilled at JavaScript can write a component. So say Don McCurdy writes a physics component. Then anyone, probably even like a kid, can just take that, put it into their scene, and then just use it from HTML. So here is kind of like some of the standard components that A-Frame ships. And here's more of some components that the community has built. And the wonderful thing is that as a framework, you don't have to rely on just the core team to build features. It's the whole community is in the mix. And yeah. So what we do with all those components is what we're doing now is we're putting them into a registry. So this is a project that we just started. People can submit components to just a flat file, and we handle all the versioning, and we use a CDN to serve all the files. And what you can do is you have a web front end, you can see all components, and they're all curated. So we ensure that they work well. We ensure that everything looks good. It's all open source, and you can just browse it, and later on you can have different shaders. We're currently working on adding more components, and later on you might even have assets. So if you ever use a game engine like Unity, this is sort of like the Unity store where people upload components and assets and sell them. But in this case, we want it to be free. And what you can also do with those components is I create a command line tool called Angle. So what you can do is you can install components straight into your HTML. So you can do Angle install physics system, and it'll just inject the script tag into your HTML. What that does is you don't have to go out and look for components and find the right version of the script that works with your scene. Angle and the registry automatically know which version of the component fits best with your A-Frame version, and it'll just install it as a script tag. And it just saves you a lot of trouble. And it's not really even the build step, it's just sticking in a script tag. And you can actually use the components from the registry in the inspector. So have you played with the inspector at all? Asking everyone.
Yeah, like we'll be telling them about inspector in the next session, but it's like they know about it.
Okay, I'll just demo it in relations to the registry. So with the inspector, it's a visual tool. It's just like the kind of like a DOM inspector. So I hit Control-Alt-I instead of Control-Command-I. Inspector, I can inspect the scene and move things around. I can poke around and see everything. So with the inspector, I can just kind of change like values. Like here's a text component. It's a third-party component, but I can still modify it. I can kind of move it around with the position, and I can just keep changing text. So these are using like different font sizes, Mozilla, India. And when I go back to my scene, it's all changed and live. If I want to use components from the registry, right here, it's where we are currently exposing a lot of components. So let's say I go to the ground and I make that a static body, which just makes it so that it pretty much just makes it a ground. It's part of physics system. And let's make all these dynamic bodies. So these are all, these components are all from the registry. So it's actually reading the registry, figuring out the links to components, and when I type them in, it'll just copy the link of it'll inject the component into my scene. So these are actually just third-party components, and the physics ones are by Don McCurdy, called A-Frame Physics System. So if I go back, I added all the physics, so now everything is, well, I think that one just fell through the floor, but you kind of get how it works. If I want to make this the word aesthetic, I can just pop in the animation component. Let's see, where's the animation? Oh, I need to add it. Okay, here it is. So I just say I can make animate the rotation around the y-axis. I can just loop it, and now it will loop around. I guess that one was like a box shadow. So that's a very easy way to kind of get started with A-Frame, to discover components, to play with components, to figure out how their values affect things. And I think Ram just asked me to top 3 demos. That's a lot of pressure. Let's see. There's a lot of animated ones that look like they took a lot of work to do like fine-tune animations, like the one where it's animating physics or tennis. You can actually just try using physics and see what happens. But that looks like some work. But hopefully, when you have tools like the inspector, it makes it a lot easier. You don't have to fine-tune things as much. Since A-Frame is built on HTML, it works on React. So this was actually released. I think I created this before we officially launched A-Frame. So a lot of people like to use React, and it's kind of the hot framework of the last year or two. But it just pretty much, it's a very thin layer. It just takes, like here, geometry printed box has passes an object. It just converts it to a string so that A-Frame can understand. And this is very nice because rather than kind of combining React and WebGL, React is more of another abstraction layer on top of WebGL. So it doesn't it doesn't conflate or decouple. React just acts as a view layer, so things are very clean. Another little project I tried out was mixing style sheets. It's kind of like CSS for A-Frame. You define your components in like a CSS style. So pretend these are classes, but they're actually mixing names. So red, and they can pass in components, and then just use them from your HTML. So here's blue, and then you can kind of use it as a class. So this is blue sphere. A-Frame performance, I won't go over it too much, but we made it so the HTML is a very thin layer. It doesn't affect performance as much. We kind of did something kind of like the virtual DOM where everything is done in memory. And we kind of proved that with a painter. I think Pat showed this a little bit, but you can run 90 frames per second WebVR experiences in the browser with room scale. So this is built in A-Frame. This kind of shows that performance isn't an issue yet, and we're not really hitting it. As long as you don't go crazy and make sure you make the right optimizations. And here's a little demo of something that someone drew with a painter. So this is Lord of the Rings Gandalf against the Balrog. And this is something that Face from our team is a technical artist. He drew this just with a painter. You can just share VR paintings just with links, and that's a really powerful thing with the web is you can just share things with links. You don't have to go through a content portal or anything. And I think the last thing I'm going to show is we're working on a game called, we're temporarily calling it a shooter, but it's just like a first-person shooting game. We're learning a lot from it, and we're improving AFRIN's performance as a result of it. And we're learning a lot about how to incorporate game development into AFRIN. Yeah, so I kind of talked a long time. So does anyone have any questions? I'll go back to the camera here. Let's see. Well, it's like morning now. I think when I saw you last, it was like the lights were on, but now I can see the sun rising.
Okay. So guys, do you have any questions for Kevin?
So Kevin, here is a question from 2-3 participants. They struggle to, like let's say we have an entity and we apply a set of animations to it. Now, if we want to, reinitialize the entity to its initial state, how do we do that?
I think Kevin, you have already seen those examples. In one of the examples, the ball is dropping from the top, and this is going here and there, and this is going down. So he wants to do it in loop. So once the ball goes away, it should again drop from the top, and it should do the same thing over and over.
Yeah. So were those like multiple animations strung together? Were those multiple animations strung together? So right,
all the animations.
Yeah. So right now the animation API I'm kind of unsure of. So that's why I made my own component for it. So currently looking to improve the animation. Since it's like multiple animations strung together, it's probably better to have one smooth animation so you can control the whole thing. So I think we'll be releasing a component soon for movement patterns. So what you have is you specify several points, then the engine will automatically just draw a really smooth line between all those points, and then you'll easily be able to loop between them. But I guess you could also, otherwise you probably have to use JavaScript to restart the animation and tie everything together. So current that's very basic.
Even we thought of, I think the solution was JavaScript only. Like there was no solution in A animation for that.
Yeah, animation was a very simple API. When you want to do more complex things, you need more complex APIs.
Right. Any more questions, guys? No?
Everyone have fun? Probably were tired.
Yeah.
So we have got them joined on Slack. Few of them will be joining now, and they're also there on the Telegram. So with the Indian community. So yeah, if there are any more questions, they will maybe put up on the Slack or on the Stack Overflow, and then maybe you can just take a look at that. So for now, they're just exploring many things, and they are trying to improvise on the demos which they have created, and few of these the people here are still working on the demos, and in some time they will be up on the GitHub for the deployment.
All right, cool. Yeah, ask me anything on Slack. I'm on like all day, every day. I downloaded the Telegram app. I'll try to join it. I never got around to it.
Okay.
Yeah.
Yeah. So any other words after looking at the demos which you have seen?
I think I gave one-line comments to each demo. Yeah. So WebVR, I firmly believe it's the future. Currently, not many people have headsets, so everyone's kind of getting dragged along. Only people with high-end headsets are like kind of dragging the people without headsets along. But as things become more cheaper and more standardized, so you can start building cooler and cooler things.
Okay, Kevin. Cool then. So we'll now like maybe wind up our session in next couple of minutes or in one half an hour. So okay. This was very interesting and nice to see you here. And yeah, you can expect many questions from these guys in upcoming days, as in when they will be moving on to the advanced concepts of A-frame.
Okay. All right. I'll see you already later. Thanks for having me.
Yeah. Okay. Thank you very much, Kevin, and have a good evening, good night, or whatever is the time it
Have a
was.
good morning, whatever night. I don't know. All right. Bye bye.
Okay.
Bye-bye.
Bye bye, Kevin.